GitOps, Git as the single source of truth for operations. Agenda, infrastructure, operations models. GitOps history. Why GitOps? Reconciliation lifecycle. Getting started. Basic workflow, principles and practices. Infrastructure operations model. Operating infrastructure means deciding how changes to servers, clusters, and applications actually get made and tracked over time. If a change causes an incident, a good operations model makes it easy to see exactly what changed, when, and who approved it. Almost every team running infrastructure at scale eventually needs a consistent, auditable way to make changes. Any team working across multiple environments benefits from one repeatable process instead of tribal knowledge per environment. Making infrastructure changes by hand, environment by environment, doesn't scale. ClickOps and GitOps. ClickOps means making changes directly through a console, CLI, or SSS session with no required record of what changed or why. GitOps instead requires every change to start as a commit to Git, reviewed and merged before it ever reaches a live environment. ClickOps, console clicks, ad hoc kubectl edit, no required review. GitOps, pull request merged, automatically reconciled, reviewed before it's live. Problems faced with ClickOps. Single point of failure. One undocumented manual change can be impossible to reproduce or explain later. No natural audit trail of who changed what, when, or why. Configuration drifts silently across environments that were once identical. Hard to roll back a change that was never recorded as a discrete, reviewable step. Every operator ends up with their own tribal knowledge instead of a shared written history. Misses out on code review as a safety net before a change reaches production. The GitOps system. Desired state for infrastructure and application is declared as code and stored in a Git repository. A reconciler, agent or controller runs continuously comparing the live environment agent against what's declared in Git. When drift is detected, the reconciler can alert or automatically apply the changes needed to correct it. Well-known, yeah, well-known tools that implement GitOps, Argo CD, Flux, Terraform Cloud, VCS-driven runs. GitOps advantages. Every infrastructure change is reviewed through the same pull request process used for application code. Git's commit history becomes a complete permanent audit trail of every change. Rolling back is as simple as reverting a commit, not remembering manual steps. Configuration drift is detected automatically instead of discovered during an incident. The same workflow scales from one environment to hundreds without reinventing process. Encourages small, incremental reviewable changes over large, risky ones. Everything is a pull request almost. One huge benefit is that in GitOps, almost every change to an environment starts life as a pull request. Code review becomes the approval gate for infrastructure, the same way it already is for application code. CI checks can validate a proposed change automatically before a human ever reviews it. Merging a pull request is the moment a change becomes real. Reconciliation handles the rest. This turns operations from something done to a system into something proposed, reviewed, and approved like any other code change. Declarative and reconciled. Declarative. Describe the desired end state, not the steps to get there. Pulled and reconciled. An agent inside the environment pulls and applies changes. A GitOps change, start to finish. A single pull request carries a change from proposal through to a live reconciled environment. A generic reconciler config. Most GitOps reconcilers share a similar shape, a source, a target, and an interval. History. The underlying idea builds on infrastructure as code, practiced for years before the term GitOps existed. Weaveworks coined the term GitOps in a 2017 blog post describing how they operated Kubernetes using Git and CI/CD. Tools like Flux from Weaveworks and later Argo CD turned the idea into widely adopted production-grade software. The Open GitOps Working Group under the Cloud Native Computing Foundation (CNCF) later formalized four core principles that define the practice. Now a standard practice for operating Kubernetes and cloud infrastructure across much of the industry. Why GitOps? Auditable. Every change traces back to a reviewed version commit. Recoverable. Rebuilding an environment is as simple as pointing a reconciler at Git. Consistent. The same process works whether you manage one cluster or 100. Secure. Reconcilers can pull from Git without ever exposing broad cluster credentials externally. Collaborative. Infrastructure changes go through the same review culture as application code. Backed by a growing ecosystem of tools and a CNCF working group defining shared principles. The reconciliation loop. The reconciliation loop is the continuous running process that keeps an environment matching Git. Compares the declared state in Git against the live state of the target environment. Applies only the difference, not a full tear down and rebuild on every reconciliation. Never assume a manual fix will last. The next reconciliation will revert it back to what Git declares. GitOps lifecycle. Propose a change, commit, pull request, review, approved, merge, agent applies it, reconcile. A change is committed, opened as a pull request for review, merged once approved, and then automatically reconciled into the live environment. Getting started with GitOps. This leads us to the three steps that bring an environment under GitOps. Pick a reconciler. Select a tool like Argo CD or Flux that fits your platform. Structure your repo. Lay out environments and applications clearly in Git. Connect the environment. Give the reconciler read access to your Git repository. Basic workflow. Select a reconciler, right? Mm. Build once, deploy many places through a pull request workflow and reviews and approvals. Committing, reviewing, and reconciling. Some call commit, review, and reconcile GitOps everyday loop. Small, frequent commits are easier to review and safer to roll back than large batches. A reconciler applies changes automatically, so merging is effectively deploying. Drift is corrected on the next reconciliation cycle without anyone needing to notice it first. Supports many workflows, single environments, multi-cluster fleets, progressive delivery. Works the same whether the target is Kubernetes, cloud infrastructure, or both. Any questions? Thank you.